Hello everyone. In this tutorial I will explain you some of the important Docker concepts by Dockerizing Kause application. So let's start with some basic concepts you need to know before jump into Docker commands. You might have known that containers are fundamentally changing the way we develop, distribute and run software. Within the next few years, developers and operations engineers should expect to regularly use containers in some fashion. If you were software engineer, you might have experienced this. Your project works fine on your machine, but when you move your project to different machine, it may not works properly. It occurs mostly because of some dependencies problem or changes in the environment. This is one of the main problems that Docker solves. Docker provides the ability to package and run your application in an isolated environment called containers. Docker originally used Linux containers but later changed to run C, or formerly known as lib containers, which runs in the same operating system as its host. This allows to share a lot of the host resources. So let's jump into some Docker commands. First, you need to install Docker in your machine. I am using Ubuntu version 18.04. By far the best way to install Docker on Linux is through the installation script provided by Docker. Docker doesn't have many requirements, but you do need to be running a reasonably modern kernel. Also remember that you need to be running on a 64-bit architecture. You can check this by running uname-m. The result should be x86-64. The official instructions will tell you to simply run curl command. But I highly recommend you to inspect the script before running it to verify that you are happy with the changes it will make to your system. So let me download the script. Okay, now give execute permission to the file. Then we are good to go. But I already installed Docker in my machine, so I don't need to install it again. Okay, now Docker is installed in your machine. Next, we need to create a group for Docker and add the current user to that Docker group, which makes the Docker available for that user. Otherwise, it only can be accessible by root user. Sudo usermod -ag Docker. This will create the Docker group, if it doesn't exist already, and add the current user. You'll also need to restart the Docker service by typing sudo service docker restart. We have completed the installation procedure. We can verify that whether Docker is installed or not by typing Docker version. Perfect. For listing all local images, run Docker images. We don't have any images currently. We can use Docker search command for searching images in Docker Hub. By default, this will list first 25 images that matches our criteria and ordered in descending, with the most number of stars given by user. You need an internet connection for running this command. Okay, let's run some Docker containers. Debian image. This may take a little while, depending on your internet connection. So what's happened here? We've called the Docker run command, which is responsible for launching containers. The argument Debian is the name of the image we want to use. The first line of the output tells us we don't have a local copy of the Debian image. Docker then checks online at the Docker Hub and downloads the newest version of the Debian image. Once the image has been downloaded, Docker turns the image into a running container and executes the command we specified, echo hello world, inside it. The result of running this command is shown in the last line of the output. If you run the same command again, it will immediately launch the container without downloading. That's right, we have our local copy of image. The command should take around 1 second to run, which is astounding if you consider the amount of work that has happened. Docker has provisioned and launched our container, executed our echo command, and then shut down the container again. Next, we can ask Docker to give us a shell inside a container by typing the following command. This will give you a new command prompt inside the container, very similar to SSHing into a remote machine. In this case, the flags -i and -t tell Docker we want an interactive session with a TTY attached. The command /bin/bash gives us a bash shell. Let's make some changes. Okay, we have created a text file with name demo, then renamed it with test file. When you exit the shell, the container will stop. Leave the container session running and open a new terminal. Try running Docker PS from the host. This tells us a few details about all the currently running containers. Note that Docker has given the container a readable name that can be used to identify it from the host. We can get more information on a given container by running docker inspect with the name or ID of the container. There is a lot of valuable output here, but it's not exactly easy to parse. We can use grep or the format argument to filter for the information we're interested in. Let's see the IP address of the running container. Both give us the IP address of the running container. But for now, let's move on to another command, docker diff. What we're seeing here is the list of files that have changed in the running container. Docker uses a union file system for containers, which allows multiple file systems to be mounted in a hierarchy and to appear as a single file system. The file system from the image has been mounted as a read-only layer, and any changes to the running container are made to a read-write layer, mounted on top of this. Because of this, Docker only has to look at the topmost read-write layer to find the changes made to the running system. You will get a list of everything that's happened inside the container by running docker logs command with the name of your container. Now exit the shell. This will stop the container. If you run docker ps, you should see there are no running containers. However, this doesn't tell the whole story. If you type docker ps-a, you will get a list of all containers including stopped containers. An exited container can be restarted by using docker start command. To get rid of the container, use the docker rm command. If you want to remove all your stopped containers, you can use this command. Note that the -v argument will delete any Docker managed volumes that aren't referenced by other containers. You can also use rm flag to docker run command, which will delete the container and associated file system when the container exits. Let's move on to create a Dockerized Causa application. I am running a Debian container and installing packages such as Causa and Fortune. Let's run that executable file. Awesome. Let's keep this container. To turn it into an image, we can just use the docker commit command. It doesn't matter if the container is running or stopped. To do this, we need to give the command the name of the container and the name of the repository to store it in. The returned value is the unique ID of our image. Now we have an image with Causa installed that we can run. Great. But there's a problem. If we need to change something, we have to manually repeat all these steps. For example, if we want to use different base image, like Ubuntu or CentOS, we would have to start again from scratch. The solution to this is to use a Dockerfile to create an automated build for the image. A Dockerfile is simply a text file contains list of instructions to create a Docker image. I am going to start by creating a new folder for this example. And I am creating a Docker file inside that folder and inserting some instructions into that file. The from instruction specifies the base image to use. This time, we have specified that we want to use the version tagged wheezy. All must have a from instruction as the first non-comment instruction. Run instructions specify a shell command to execute inside the image. In this case, we are just installing Causa and Fortune in the same way as we did before. We can now build the image by running the docker build command inside the same directory. Then we can run the image in the same way as before. But we can actually make things a little bit easier for the user by taking advantage of the entry point Dockerfile instruction. The entry point instruction lets us specify an executable that is used to handle any arguments passed to Docker run. Add the following line to the bottom of the Docker file. We can now rebuild and run the image without needing to specify the Causa command. Much easier. But now we've lost the ability to use the Fortune command inside container as input to Causa. We can fix this by providing our own script for entry point, which is a common pattern when creating Docker files. Now create an entrypoint.sh file with the following contents and save it in the same directory as Dockerfile. Don't forget to set executable permission for that file. All this script does is pipe input from Fortune into Causa if it is called with no arguments. Otherwise, it calls cowsay with the given arguments. We next need to modify the Dockerfile to add the script into the image. The copy instruction simply copies a file from the host into the image's file system. The first argument being the file on the host, and the second is the destination path. Try building a new image and running containers with and without arguments. Excellent. We have Dockerized our cowsay application. For the next video I will show you how to work with Docker registry. There is a lot more to go in Docker. If you like this video, please subscribe to my channel. Thanks for watching.